Chapter 7 deals with the concept of probability. And when we have probability, that's kind of our chance. And we need to just address it somewhat in statistics, because what we're looking at in statistics is a sample. Remember, sample measures are called statistics. And what happens is that's going to produce some uncertainty because we don't have the population. So because we're looking at a sample, there's uncertainty about the population. We've only gotten to see a snapshot, not the entire thing. So we need to know a little bit about chance. Chance is a proportion. And we studied proportions in the last chapter when we looked at those percentages of the area under the curve. And this chapter is going to tie that in to the rest of statistics. And when we look at chance here, or probability, what we're focusing on is on the percent. In other words, the outcome that we're going to get over the long run. If I was to repeat this over and over the long run, what percent of the time would I get a particular outcome? With probability, we have relative and we have personal frequency. So relative probability is relative to the simulation that we're going to run, and personal probability is just all about you. So this is going to come from what we call a simulation, from an object being tossed over and over again. And we actually have a name for that simulation. It's called a probability experiment. And what we do then with this probability experiment is we use it to actually predict long-term behavior. And what we use all of these for is to help us make decisions. These probabilities will let us know, hey, if I know it's going to rain today 80%, that's a decision I'm going to make, is to probably bring my umbrella. So again, we use these to help us make decisions. So an example of a probability experiment or a simulation is just if I flip a coin. If I repeat it over and over again, almost 50% will be heads, 50% will be tails. Not initially, but in the long run. I might roll a single die. That might be my probability experiment. I might draw cards from a deck. So those would be experiments or simulations. The outcome is the result. And it's the result of a single trial. So the result of a single trial might be a head or the tail. It might be a 1, 2, 3, 4, 5, or 6 if I'm rolling a single die. The sample space is different than the outcome. The sample space is going to be the set of all possible outcomes. It's not the single outcome, it's the set of all possible outcomes. And a key to this, and knowing all the possible outcomes, is that the order matters. Now that might not make sense here until we look at an experiment. When I flip a coin, I have one item that's going to happen. I'm going to get a head or a tail. That's my sample space. Notice I put those set brackets because I'm talking about a set. It's all of the outcomes. When I roll a single die, all of the outcomes would be the numbers that I could get on the die, not the one I did get. When I flip two coins, this is when order matter comes into play. I might get a head and then a tail, or I might get a tail and then a head, or I might get two heads in a row or two tails in a row. But notice the head tail and the tail head are two different. So let's find the sample space of having 3 children. The easiest way I think to do this is to say my first child, I define what it's going to be. After my first child, I could either have a boy or a girl. My third child could have been a boy or a girl, a boy or a girl. So if you look here, you have the different outcomes, which would be boy, 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 from this top branch, boy, boy, girl from the branch below, boy, boy, or boy, girl, girl. Now, that produced 4. Well, what if I started with a girl first? Then I could have went girl, girl, boy, girl, or boy. So it would have been girl, 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 boy, boy, girl, or girl, boy, boy. So it's just switching the letters. So if you notice, those are all of my sample space elements. If I wanted to find the sample space of rolling a single die, that would be these following numbers. Now rolling 2 would be totally different. So if I want the event, and maybe my event here we're going to define to be the subset, and I want mine to be the subset of rolling a pair of dice. Well, if I want my dice to be even, I'm adding them together. So if I was to add them together, 1 and 1 make 2, 3, 4, I would have all these numbers up until I got 6 plus 6 is 12. So for my event to be even, 2, 4, 6, 8, 10, and 12. For my event to be odd, 3, 5, 7, 9, and 11. Greater than 3 would be 4, 5, 6, 7, 8, 9, 10, 11, and 12. Notice I begin my set and I close my set. That will conclude the first lecture. We'll look at mutually exclusive events in the second lecture.